In the transfer printing processes, we will be taking this as a last lecture. So, this topic we will try to wind up today. Before this, let us see what we had done, and we had understood in the last time how the dye gets transferred from paper to the fabric and what is the mean free path. So, in the transfer you have the diffusion of ink from layer to the vapor, the diffusion of the vapor between the air gap, and absorption at the fiber surface, and then diffusion. So, these are the things which take place, which are obviously governed by the approximately the ideal gas laws. So, on the paper we have talked about what kind of paper, we have also talked about the type of dyes that we may need. So, the binder also has some role to play, and the role obviously is that till the dye is transferred, it should hold the dye on the paper in the design in the specified area. So, it is also expected that this particular type of a binder would not have affinity for the dye, and if it has no affinity for the dye, then the diffusion through the layer would also take place in a faster way, and much less will be retained in the layer, the polymer layer which we have. Because our aim is only till the time it has been used for transfer, but this time probably is longer than, let us say, in conventional printing, when we have a binder or we have a paste which has to be dried and then fixing takes place. In this case, this paper may be stored for a longer period before somebody uses it. But this binding is relatively simple binding. You are not really expecting any cross linking to take place, it is just that there is a layer. And unlike pigment printing, where you had to wash your fabrics, where the binder had a role of increasing the wash fastness, here something like that is obviously not expected. So, as such it is a simple process, but still you need to bind, and obviously it should not have much affinity. Some of the examples which we see here written as a polyvinyl butyryl, which has a structure of something like this, which is a polymer. So, you can make a polymer layer. Other things which you are quite familiar, ethyl cellulose or cellulose acetate and carboxymethyl cellulose, all of them can be used, and so we hope that transfer will take place. But the question sometimes comes, how much of a binder and how much of a dye? I mean, if the ratio of binder and the dye changes, then obviously the film layer becomes thick if the binder is more. That means if you have lighter shades versus darker shades, so the percentage transfer or transfer efficiency can change. You may like to have such type of binders which would be relatively more independent of this concentration of a color ink in the binder, which may not happen always, but you would like something to happen. Between these things, one reported study says the dye absorption rate versus the dye and thickener ratio. That means how much is thickener, which is basically this binder which actually dries on the thing. So, these four we are talking about, and the dye. If you see on the x axis that you have a dye thickener ratio, where in the first is 2:1 and goes up to 1:3. And so, what you generally see is, at least from the look of it, these two types of binders are relatively more inert to this ratio, the change is not very high. So, when you do a print which may have different shades where the dye may be very low or very high, you will still have the transfer. I mean, if the transfer rate is same, then this can happen. If the transfer rate becomes very different, then the time of transfer you are keeping fixed, 30 seconds or whatever, then the expected tones which are supposed to be on the paper may not get transferred exactly in the same manner the way you would have expected it, because the rate of transfer may be different, and therefore, the time required for a complete transfer may be different, and so things can change. So, it would be nice that if you have binders which generally are so inert to the dye, they have no interaction, and the film is also relatively more amorphous rather than compact film. The machines for the transfer printing are very simple machines. The only thing that you are required is that there should be a plain surface where you can put your fabric and the paper, and you should be able to apply some pressure and heat. These are the only things that are required, and therefore, in some cases the speeds can be also very high in continuous machines, which speeds you can never think of whenever you do a conventional printing, which is quite interesting. So, you can have something like a flatbed transfer press, which may be for garments, piece goods, and because if you have this type of a arrangement where the pressure is applied intermittently, so you cannot obviously have continuous flow. So, piece goods are there, because transfer printing also used for garments and piece goods. Some such type of machines can be simple, or sometimes people only use your own iron and then put the design wherever you want, and then you can also get. So, it is a simple way of looking at, but of course, when you have a machine and some automation, you will have better control of temperature, which is obviously required. Now, you know that if temperature difference is there, things can be very different, and uniform pressure applied on the whole surface, that is an important part. If that can be done, the life could be easy. Simple process of a flatbed type. If you look at a continuous type, this print roller, which is a large roller, it looks like a familiar kind of a sight. A roller printing machine also looks like this, but overall this configuration is quite similar to a palmer dryer, where there is material entering from one side and exiting from the other side, and the roller is quite big, and so all the process gets completed, should get completed. If you want to give 30 seconds or more, it should be possible to complete the process within this area. So, you have a blanket, you have a paper, and you have the fabric entering from one side, getting out of the other side. At a contact time of 20 seconds, some of these things, based on the type of fabric and the type of design, you may be able to achieve very high production rates, which you will never ever think of any other process that you can think, because you are at a higher temperature. Transfer is in a vapor form, and it is clean process. So, this advantage nobody can say that does not exist. In case this itself is the thing, and if you have the same design and the same paper and everything is there, you may just be able to make money on standard designs, like if you have checks and dots and little small thing which are popular, then you can keep doing this at a faster rate. Sometimes if the fabric is thick, the GSM is high, then you may require some vacuum, so that the dye is facilitated to move in the direction of the fabric. Sometimes not this machine, but a flatbed machine could be used also for carpet printing, where you may have to use vacuum to ensure that the dye vapors go in the direction in which they are expected to go. So, two things obviously these machines are doing is reducing the air gap and of course maintaining temperatures. Here one important thing is that you keep some kind of vacuum, and you got to provide a vacuum seal, which means that this area in the whole chamber, as it moves in and the things move in and come out, is relatively more stable point and there is no gaps. So, this itself is a, in some sense is a little more complex technology, because if something is entering and if you pressure put too much pressure, then also you have a problem of either paper tearing or the fabric getting compressed. But if you do not do that, then you can't maintain vacuum. So, there will be very few continuous processes you may have seen where the process is happening under vacuum. Mostly it is all atmospheric pressure, all continuous processes are atmospheric pressure, but doing anything under vacuum obviously requires special seals from where the fabric can enter and come out without additional tearing, pressure or torture to the fabric. So, that is what we had learnt about sublimation transfer, which obviously is the most popular, and in India also there are smaller companies, not so big companies, who are making paper, transfer paper in and around Delhi and other places as well, and they are able to sustain their business. And what we realized obviously in this is polyester and dispersed dye. All other methods have been fascinating or big challenges actually to anybody who is a technologist. These are big challenges which somebody would like to take, and some people have taken it as a challenge. So, what it means is that fabrics which are not thermoplastics, we do not respond to dry heat and are hydrophilic to begin with, the dispersed dye obviously cannot be used. But people have tried this wet transfer. The only thing one should appreciate in this is that when you dry and transfer, and if you want to in a wet state, the stability of the paper and therefore the interface of the paper and the fabric surface may not be so steady. In case it is not so steady, then there can be problem. In a dry heat, paper is quite stable, the fabric anyway keeps working, and so there is no apparent shift between the two, and if that happens in any case, then obviously print quality is going to go down. That is one, and of course there is a challenge of finding such type of dyes and transfer systems which do quick transfer, because this will not be very high temperature. If it is not a very high temperature, obviously rate of transfer will be different, and so you may require more time sometimes. And then stability of the paper sometimes can be an issue. And so theoretically speaking, this technology, although a lot of people have tried, has not become commercially very successful textile. Wool, I mean, it has been tried on cotton also, has been tried on wool, and some of the work, in fact some of the commercialized work is what we can look into. So, the principle basically remains the same, but the medium is now water, because you are now talking about hydrophilic material, which is the fabric, and so you have similar mechanism as you are looking at any other printing mechanism. So, diffusion controlled process, and one of the processes which was commercialized was called the fast tran process. Steps of this particular fast tran process, they used first linazole reactive dyes, and the paper that were printed were called the Equatran W papers, which are commercial. One important thing is that because sometime they will be coming in contact with water, so some coating etc. was required. So, linazole dyes on paper. The fabric obviously had to be pre-padded. So, there is liquor, some viscosity is increased, it is not very low viscosity, but still it is a quite low viscosity. And this particular method did the transfer above 100 °C, which means a bit of a steam is generating 30 to 60 seconds, and then washing off to remove the unfixed dye. So, any paper at 106 degrees for whatever little time that you have in moist condition can have an issue of crumpling, uneven shrinkage, and so on and so forth. That problem of course was there. So, they worked on various systems, and they also tried to make transfer machine specifically for wet transfer, and the machine was marketed as dew print. So, basically as if condensation will take place and things like that. So, this is the way they marketed this machine, and the important feature of that machine is a set of rollers. You see, it is the same kind of a roller which was being used for a continuous transfer of heat transfer, but then you had blankets, but instead of that this has series of rollers everywhere which were applying pressure, and this pressure was also continuously increasing from entry of the fabric to the exit of the fabric. So, therefore, this is a special machine, right. So, exerting a steadily increasing pressure up to the stage which was equal to the pressure of a padding mangle, because there is a pre-treated fabric. So, whatever you wanted to add to the fabric, you do a padding treatment. So, you apply some pressure and get some expression. So, in the beginning the pressure is less when the transfer is taking place, and the pressure increases as this fabric goes from this side to this side before exiting, just making sure that the initial pressure not exceeded, that is all, but hopefully you would have transferred all the dye. So, this machine was special till that time. This machine was brought into the market. Wet transfer was not very nice, and the people who actually became more interested ultimately were the wool people. So, you have a good research institute in Australia, and of course, a nice work being done in UK on wool. So, they were obviously quite interested in doing this wet transfer printing of wool. So, everybody was in a way fascinated with the transfer printing. So, you wanted to have wool being printed. Wool in any case is relatively much more rougher surface compared to any other surface, but it was an attractive process. So, people wanted to work around.
Why do we need to keep increasing the pressure?
Right. Initially, the material when it goes, you allow some water to get heated, some steam to get generated, and then because the concentration of the dye on the paper is high, So, you expect the transfer will start taking place. By the time it goes, the dye may have partly gone, and so you want more and more to go, as if you are squeezing the dye in and holding the paper all along also, so that there is no slip. That is one. So, at the end, and not more than mangle means that you do not really, if suppose 100% expression is there, the transfer you want only of the liquid, and you are not so much interested in transfer of the water. If the water, if you put more pressure, the water and the dye can also come out of the fiber in a reverse squeeze mode. So, you do not want the pressure to be higher than that. This treatment is just, I will give you the next one. So, this is a reactive dye. So, you have basically an alkali and some viscosity modifier, so that the spread it does not take place so much. You see, like when you have a tailing effect in a dyeing padding system, you add sodium alginate and some such high molecular weight compound, so that the tailing is reduced. So, here also bit of a viscosity modifier, but still it is a padding process and not a paste process, and that is the kind of thing basically. Alkali is there because you like it to be fixed. So, wool people like this dye more, which is the acrylamide dyes, which have this type of a reactive group, which has got a possibility, there is a double bond here. So, there is a possibility that you can react from here. There is also a possibility that the bromine can come out and also a reaction can take place, and so the fastness of these was considered to be better. So, various reactions are possible with this linazole. So, from the wool point of view, the one process which has been commercialized was using these dyes. So, the challenge obviously was to create all types of shades, so that you can get all tones.
So it may react with the paper also.
Yes, that can happen, and therefore, they do some coating on the paper. Otherwise, to make the paper stable, a certain coating which will be relatively more hydrophobic, so that the dry transfer takes place more and does not go the other side. So, from the amino end group of a wool, one can expect various types of possible reactions. One is addition reaction, where the double bond gets modified and you get a link like this, which called addition reaction. Then the bromine can come out also, and then double bond remains as it is, and the wool gets attached in this manner. Here the wool has been attached in this manner. There is also a possibility of two wool molecules joining, A and B. So, sometimes it is considered as if it is a bifunctional reactive dye, but because the functional group actually is only one. This is the functional group. So, you have the same molecule reacting with two end groups of the wool. So, two molecules of wool could be actually reacting. The probability is very less, because the moment first one reacts, getting the second one obviously has less opportunity, and the steric hindrances will not help the second reaction very easily. So, either this or that is possible. It is, and then if double bond has to react, then it can react and make ethoxy kind of a link or epimene type of a link, which is relatively more stable compared to, not exactly stable I would say, but that reaction also is possible, but that means that double bond, but double bond can remain as it is. It is better that the bromine goes out from the reaction rather than stays, that will be better, because the bromine is attached to by a single bond to a aliphatic carbon, and so relatively easy to come out. So, wool people were the ones who first commercialized this process, and because of them the dye manufacturers also worked hard and tried to give many shades if possible. Another process which was called the Cara-Trans process, but this strictly speaking is not a wet transfer, but it does combine both the processes in some sense. So, dye is sublimable, the dye is sublimable. So, they are using in a way a dry transfer process, but the fabric has something else also. So, what they use is a dye which is sublimable dyes, but they are also in a way mordant, or the one which can be complexed with the metals. So, if something can make a complex with the metal, and the metal ions are on the wool for example, then the same dye after transfer can now be combined, and so wash fastness could be high. If normal dispersed dye is used and it gets transferred also, because it has no affinity, so it will keep coming out without much problem. But in this case, if it is metallized, and then it will not come. So, this was one process which was also commercialized. So, wool is pre-treated with some surfactant, an acidic environment. So, you have more positive charge. Generally, they found lactic acid was the one which was more giving more positive results, and chromium they used, chromium 3 they used as some salt on the thing. So, you pre-treat the wool with surfactants in this thing, and then you do the normal transfer at 200 degrees for 30 seconds or whatever, and then further take it for steaming. So, there is a post treatment which is a long period. So, you can appreciate it cannot be the process which is as fast as the dry transfer. So, after the transfer has taken place, you are still going to speak. Look at the comparison, there is a 30-second versus 30 minutes for fixation. Urea may also be available in the pre-treated material, and then wash it off. So, dye and metal complex is formed, which predominantly is 1:2 metal complex. 1:1 also can form, but 1:2 is maximum that they found. So, once the metal complex is formed, and 1:2 dye is 1, and so the chances of its getting off are quite less because of the coordination bonds that the metal complex is going to make. So, this chelation is what happens here. People have tried using cobalt and iron also for fixation purposes. Again, we are talking about wool only, but the moment you change the metal, the tone of the dye finally on the fiber is different, because they are also once they coordinate, the amount, the kind of light that is absorbed and reflected are different, and so you get a different shade. So, different metals are going to give you different shades. If they are too different, then you may not like it, and therefore, you can appreciate it will be very difficult for somebody to print a photographic print on this with this kind of a dye. Theoretically possible, but if choice of a metal ion itself changes the shade, the photograph may be very different. So, but normal textile prints you would not have any problem, invariably color could be any. So, light orange versus dark orange is as good as far as design is concerned, but not the photograph. So, very difficult to print photographic prints by wet transfer, although it can be. You can take a photograph and print it, but what would look may not be same, because in photographic true transfer is required. So, this process obviously had some concerns of using heavy metals, but if you are using it for dyeing, then you can use it for printing. Otherwise, chromium and cobalt are not very preferred materials, although they found the chromium is the one which gives quite true shades of whatever type with these dyes, metallizable dyes. Iron gives something else. Iron from environment perspective is acceptable, chrome and cobalt obviously not so much. So, in some sense it's a combination of a dry transfer, completely dry transfer, and some wet systems also, some modification, but they were able to actually make it a patent and actually get the process. Therefore, some interest were developed, and the maximum interest obviously is in Australia as far as the wool is concerned. So, wool was important for them, so they tried other methods also, which we had considered earlier also, esterification, etherification of the hydrophilic fiber. So, for wool they tried benzoylation. So, one is that you have changed the hydrophilic group to aryl groups, so making it more hydrophobic, so reception will be more. Or one of the thing was benzoylation to increase the affinity of dispersed dyes, and one of the processes used benzoic anhydride instead of benzoyl chloride and used through DMF, which they found was giving better. Now, but the important thing is using a solvent which is not a regular solvent in a printing industry will always be some challenge. So, little bit one or two points on the film release transfer printing also. Again, well, release for purposes other than the textile printing are still being done at levels which are very high commercial success, but transferring film onto textile has been tried. So, these also processes for textile are not very popular, printing particularly, because even if the film gets transferred, the textile has to be washed and then ironed, re-ironed, re-washed, re-ironed. So, the requirements are slightly different, but for various reasons people have been using some kind of a binder, some kind of film on the thing, rubberized prints for that matter, where the abrasion resistance is not so high, but for fashion reasons people do print. So, some of that type of thing I believe can be done by using a film release. So, what it means is the film is there and it gets released, and the whole in some sense is being, you have a transfer. So, this process means depositing the printed image as a film onto the textile material. So, as long as the film likes the ink or the dye, it is okay. So, you are not really hoping that the ink likes the fiber. As long as the film can be attached, because film is a high molecular weight system. If it can remain as a film, therefore, if it gets transferred, then the whole of it stays onto the textile. As long as it stays on textile, you have the design, and when you find for various use and abrasion resistance, it is not there, so you do not have. So, inks are also called plastisol ink. So, there is a, because there is going to be a film formation, and therefore, it is like a plastic being made. So, plastisols are there, and you can use polymers like vinyl chloride copolymers along with some plasticizers. Plasticizer, is a compound which reduces the glass transition temperature of polymer and film in this case. So, it remains flexible, right. So, if you a large number of polymers which are flexible polymers, you have plasticizer in them. Sometimes the plasticizer with time can ooze out, and you may have seen with time the polymers, the sheets, they become rigid with time, because the plasticizing can ooze out and come. So, chlorinated paraffins or crysyl phosphate or dioctyl phosphate, these type of plasticizers are there along with pigment. They are dispersed properly to make a plastisol ink, which is used to print a paper. So, this paper, which is a release paper, must release the whole film, should not have so much of a problem, and if that is true, then things can happen. So, some of these papers which are commercially used for such type of things are coated with complex chromium complex of stearic acid or myristic acid, and once it is there, then as somebody just pointed before also, the affinity towards the paper becomes less. The film may like to just get out of the surface whenever given an opportunity of pressure or temperature. So, this is the C13 type of an acid, which is called the myristic acid, and this is the common C17 type, which is stearic acid. But because they make chromium complex, something like this happens. So, chrome complex are cationic, and this positively charged moiety gets attracted to generally negatively charged paper surface. Most of these surfaces, as you know, are negatively charged little bit. So, the thing is that you have a hydrophobic end here and a hydrophilic end here. If hydrophilic end through the chrome etc. goes onto the surface of the fabric, so what remains outside the surface of the fabric is a very hydrophobic material. So, the molecule of the agent thus becomes oriented with the hydrophobic moiety pointing away from the surface. So, all the C13 groups are pointing, or C17 groups are pointing out, and because they are pointing out, they generally provide a relatively effective release of whatever film that you have had. So, linking with the paper is least, because it is now being covered in some way. So, you have a release paper, then you can print actually by any method. People can use screens to print. Sometimes it may have a additional backing layer, because the plastisol print is very thin. So, you may have a backing layer which can give a bit more stable, so the more film could get a bit of a easy transfer. That is all I think we are looking at the possibility of transfer printing. So, this can be done, this kind of a thing can be done at different temperatures depending upon what you are doing, up to 190, time could be all. So, what happened? The film gets softened and forced onto the fabric. You wait till everything gets cooled and then you can remove the paper. So, simple process, but we now know that there is something called a film which is on the paper, which finally gets transferred onto the fabric, may not be able to withstand the rigors of textile use, but it is done. So, simple sequences of this type where there are many heating elements along the surface or some kind of a blanket which is forcing the paper and the fabric together, and one can hopefully get the transfer or release of the film from the paper. So, whole thing, the printed element, printed part can come out. So, that is all we would like to talk about. So, melt release is not so much of a use, but people had tried this. You can try to get some papers and learn about it. Some of the binders that we will discuss is cellulose acetate, ethyl cellulose, carboxymethyl cellulose. You can look at the chemistry of these materials so that you know what differences they have, and you can try and correlate with their effect on the transfer rate during sublimation process. All right, so we stop this. So, the transfer printing we are now closing, and we can talk about next, which we will call as a digital printing.